Hello and welcome back. Today I have another frequency counter and this time it's from Racal. And before it was Racal Dana, so it says Racal Instruments actually. And it's a UHF frequency meter and it is the 9918. So 9918. It's from around 1975 if I should guess. And it is a 2-channel. It was sold to me as a broken unit, so it is probably not fully working and we need to find out what is working, what is not working. So let's have a closer look. This is it from the front. Yeah, with the lighting it looks a lot better, but it's actually kind of dirty. You can see the years. This is a bit weird. It says danger of radiation. So I'm not sure if it has a rubidium oscillator inside, but I don't think that was an option in that time. So it's a UHF frequency meter, the 9918, and yeah, 2-channel. This looks like an option, the LF multiplier. So that is, you can see the lower frequency with a lot more digits in the end. Nice. First input is I think that was 10 Hertz all the way up to 100 right here. And here it says the second is 40 all the way up to 560. So by the way, it's kind of bluish. And I think this is not the original color. I think the original color was kind of dark grayish. We have power settings all the way from 94 all the way up to 264. And 45 all the way up to 450 Hertz. So the highest voltage is in W and Z. And that's exactly where it is set to. So that is all fine. I see remote control here. I see BCD output here. If I need to believe all the options, it says here it has option 04B. That is one of the best big oven oscillators. So that is great. The 9, that is the low frequency multiplier. We saw that in the front. And the O2, I think is this one, BCD data output. Well, I did not mention it, but we could see in the back that there were two BNCs. One is oscillator out, 1 MHz, and also oscillator in for external reference. And there we can indeed put our external 1 MHz. So it can all run on the GPSDO. Before I switch it on, I have my power meter here, my electro parameter. It's a homemade thingy with a display I bought. And I will just put it in the power line so we can see how much power it is taking. And from there we can also see if the oven already starts to switch on and off, so we know it's hot. Some frequency counters have sort of a standby, and when it's in standby, it still keeps heating the oven. My Philips says that, and I think even the Unreach also has that. So there is always kind of 30-40 watts that is always running. So I wonder if this one is really off or it has a standby. So let's see. No, it's really off. So DC in the green, we don't look at that, and we have here the AC. Let's see, here is the power. We switch it on. If it even does that. Yes, it does. And here we have it, 25 watts. So let's see if that drops after a while. That means that the oven is warm. Okay, how many digits we have? I think it was 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. Check. Okay, it thinks the oscillator is indeed running. This seems to be a 1 second gate. Now we have, I think it's, it says here 1 second, 10 seconds. So this is a 10 seconds gate. While the oven still at 25 watts. And of course it maybe missed one. Here it is. So the internal seems to be running. Let me check how much it is because there was an output. And when we look now here, it indeed is more than 1. And that's why we are here too low. Because it counts too fast, it will miss, of course, counts. We need to wait until it stabilizes. it seems to still to be heating, so we just will wait. Yes, now we see it dropping a little bit. Now we see it a really good drop. I placed it now horizontal because maybe it was adjusted like that, and there is always a slight difference if you calibrate it in a different position, because now we are almost there, and instead of 25 we really see a difference. Now it's now 22. Now we have some overshoot, and because it is a little bit too high here, it went to 19, 18, this dropped a little bit more, so I think it is now trying to get it slowly a little bit lower, and this one is just going 999 or 10, 999 or 10, so it's just switching a bit. And I'm hoping this will drop a little bit, or if it just stays around this value, it's also good, and then we just need to adjust it. According to the manual, it's about 20 minutes, then it should be stable. And indeed, we see here it dropped even a little bit underneath the 21 watts, and it goes a little bit down, a little bit up, so it's really adjusting. And we see it is stable around this 120, so it's below a hertz here. So that is good news. The first input is working. It seems that the oven is also doing a great job, because we are here in the thousands of hertz, and it is just going 1 or 2 up, so that is pretty stable, and the device should be getting hotter and hotter because all the electronics heat up, but still the oven is regulating that perfectly fine. The first input works on 10 megahertz, so we can see if it goes up to 100 as well, and then we need to check the second channel, the little oscillator here. Then we can add a little bit more instead of 10. Now let's start with 50 megahertz. Yeah, look at that. And of course it's a little bit off because we are a little bit off here. So if we are off here 1/10 of a hertz, then that means times 10, 1 times 5 because of 550. So that is exactly correct. It's 5 hertz off. Let's see if we can indeed go higher. Can we go to 60? Yeah. And then of course we are 6 off. So that works up to 100. Can we go a little bit higher? 110. Yeah, no problem. 120. No problem. 130, no problem. 140, it's still going. Cool. 150, no. 140 is the max. Cool. Okay, first that channel goes all the way up to 140. Of course, the sensitivity will go down. Now I like to check this low frequency option. So I will put 1K. So here we have the 1K. Well, we cannot see too much. Yes, it is 1K, and maybe if we put it on 10 seconds, we get an extra digit right here. But if we switch this one over, we should really see a big difference if it works. So let's see what it does. Yes, look at that. Then we can see a lot better the 1000 hertz and even below. And then of course if we do this one and we wait a bit, then we see even lower. So that low frequency option also works. Look at this. This is 1K. Yeah, perfect. Cool, that option also works. Let's see the C channel, because something must be wrong, otherwise it would not have been sold as parts. So let me just put this one on 50 again, because it starts at 40 if I remember correct. Let's see what it will do. Switch it over to this input and switch over here. And we indeed see nothing. I think the overload circuit works because I saw a little blink. And this controls a little read relay. If it overloads, then it switches off the input, so that's quite smart. That circuit seems to work. Only, yeah, I don't know if maybe there is just a cable loose, or the read relay doesn't work, or there is really a problem with the input signal. Well, they describe the signal path as it goes to a capacitor and then going through a read relay. Then we have here an attenuator with diodes, and then it goes into this IC here. And this one you don't want to be broken, because that is that integrated Philips. It's a different type than from the Marconi. The Marconi, they are 12 volts, I think. This one is 24 volts. It's an OM335, and I think from the Marconi was a 320. But anyway, you don't want this one broken, so hopefully there is another problem. There was this limiter circuit. Here is the LED for that. That signal goes here. Also limited by the diodes, goes in the op amp here, and then it switches on and off here this light. Well, the light was blinking, so this circuit seems to be working, but it doesn't necessarily mean that the read relay is correct. Like here we have, it will switch here. Here is the coil, I think, and then it will switch the relay here. So this switch itself could also be broken, and I hope a little bit it is, or it is just a wire, because if not, we need to go look for this Philips one. If it is still available. We're talking about 1975, but not jump to conclusions. Let's just open and see. Meanwhile, we were looking at the schematic. We see that the power dropped even more. The frequency here is now even closer to what it should be. So interesting. Maybe if we switch it on longer, but I like to open it now. But I have a good feeling about this oscillator. Sometimes when I'm not sure how to open a device, I just quickly browse on YouTube on someone else's channel to see if someone knows how it's done. And this time I stumbled on the channel of Peter from Make or Repair, and he had one, so he told me how to do it. 4 screws, 2 in the side, and then you can pull it back a little bit, and then you should be able to just slide it out. So, and that is indeed how it works. I just opened the 4 screws, then you just pull it back that you have a little bit extra space, and then you can just slide this out. Here it is, perfect. Ooh, it seems like indeed a real one. Okay, from the top we see a lot of space here. I'm not sure if it's for the C channel. I'm not sure it even has a C channel, this series, but maybe written on the type number. Or maybe it can hold batteries. We have here the big oscillator, and it's the 9421. So that is indeed the 04B. So this is the best oscillator available. That is pretty cool. Look at that. Ooh, big one. 5 MHz. It's not that hot, so it's well isolated. We have here a coarse and a fine adjust. So we can do maybe the fine later, at the moment that we are ready. And maybe we need to switch it on for an hour before we start changing that. Another part that could break on these counters, that is this old IC. I think it's very sensitive to statics. I've seen in forums that people complain that it breaks and that it's very difficult to get, but it is doing part of the counting. And we have also, I think it drives even the displays here through the drivers to the display. But yeah, we've seen that all working. It's counting. We see the display working, so there is no problem there. I will be turning it so we have a look at the front from the back. So we can see the C channel better. So closer look here. Here we have the C channel. seems to be a little coaxial cable. I need to check if it is indeed stuck, but it seems to be stuck. And then it disappears in the back, but the same color coax I see here. So this could be where it goes in. And yeah, where is the read relay? We have a little capacitor. Not sure I see the diodes. I need to zoom in a bit more. But yeah, maybe this one is the read relay, and here is that Phillips, which I hope is not broken. We are again looking from the side. Here is the front. Just to zoom in on the Philips op amp here. These are these very famous chips, also famous to break, but they can do 0 to 1 gigahertz almost flat, and so that's the nice one of these amplifiers, and they were used a lot in that time. There are replacements with these Mars chips, I think, but let's not jump to it. Let's see if this is indeed a read relay, and maybe we can measure something, hopefully from the bottom without taking the PCB out. So I will be opening the bottom as well. Okay, looking at the bottom, the front right here, we can see that there is indeed already been some work done. Here this IC seems to be replaced, or at least resoldered. We see some work here, and I think this is the Phillips. We see some soldering here, but this is, yeah, probably the counter area. That works. Here some soldering has been done also. If I look at it's also an IC, I think, but the coax goes in here in the bottom with the cable, goes in the bottom, comes out here. So here we can measure, maybe it goes through a capacitor and then through the read relay, and I like to see if the read relay works, because it is normally connected except when it's not powered. So we can now see, is the connection now open, and when we power the device, maybe we even need to switch to the B channel, is it then powered and is it connected? Okay, let's start with the basics. We have a beep in. If I am on the BNC in the middle, do I have something? Yes, it comes out here. So that's all connected. And then we need to see where is the cap. And then we need to go through the capacitor. Okay, I zoom in a lot. Here the coax comes in. It goes through this capacitor, and then it needs to go here on this first pin, which is actually 8 if we count like this. And then when it is powered and the circuit is not in overload, it should come out here in pin 1 or pin 14. I don't hear any beep. Or this one. Okay, now I switch on. Okay, I switch on. Try it again without making any short circuits. That would be great. Yeah. Yeah, the read relay seems to work, at least on this pin. And then I need to try to switch it off. So the read relay seems to work, at least on that pin, but does it also work on this pin? Okay, so that seems to work. So we are already in this path here. So the signal comes out here. So then we have here these two. I think this is kind of an attenuator here with the diodes and the diodes here. So this limits us then the level to, well, 0.7 volt, I would think, no? So then we end up here, if we find some signal, if not one of the diodes is completely shorted, we should find also signal on pin 1 on the Philips. So it's becoming scary already that hopefully. So it's easy. Pin 1, enter, last pin, we go out. Maybe something basic. Do we have the 24 volts on this chip on pin 4? Okay, let's try that with the oscilloscope. I will put in 50 megahertz. We can see the oscilloscope here. B input, B input. Okay, well, we start. Let's see, I have here on the oscilloscope, we can see here it is 50 megahertz. The signal doesn't look that nice, but yeah, there could be some load on it, and it is a square wave. But we see something, so that is good. It is like almost 0.6 volt peak peak, should be enough. So then I should have it here also. It's also. Then we check on the read relay on this pin. Yes, we have also 50 megahertz on the read relay. That is good. Then on the output of the read relay we have nothing, but when we switch it on, it's a little bit less, but it is there. So that is good. Do we also have on the other output pin? Not sure which one we use, but yeah, here we also have. Okay, so it goes through the relay at least. Okay, let's have a look. I'm a little bit confused because if we zoom in here we have those two diodes that are part of the attenuator. So that means this is pin 1, and indeed on the PCB I see that this is pin 1. But then I need to see the specification sheet because I don't see a dot, but usually one would be on this side. So that means then that this one is turned around, which is weird. So let me get the spec sheet. If it's true that on the right side here that is pin 1. Google is your friend. I found it here. Indeed, pin 4 is voltage. Then we have the input in pin 1, and then we should have a stronger signal in pin 7. And let's see, can we see? Yeah, it's from 40 almost all the way to 1 gigahertz. And here we see it's 75 ohm instead of 50 ohms. But it doesn't matter too much. What else? Pin layout. Yeah, here it is. The pin is on the other side, but we can check because the last one are close together and the first one are farther away. So we should have here then input, then it is the right way around, and this is all ground, and then pin 7 is the output. Oh yeah, here it is. Yeah, so that is correct. Hand soldering, not too long, because in the end this is just a mini PCB and you don't want to unsolder it. Can we see? Yeah, here. If you go a little bit higher, you see it's almost flat. It does a little bit more here. And then there is still some signal left here, so that's why you can use it. They are used to 1 gigahertz usually. Okay, let's see, I've switched it on, so the relay should be switched. I have signal here, then it goes through the attenuator and through the read relay, and I should have signal here. Okay, this is before the amplifier. It is 50 megahertz, and it is still 300 millivolts peak with the frequency of 50 megahertz, and then all the way in the end 3 pins close by, and the last we should have a lot more if the amplifier works. And we have nothing. No, nothing on the output. Okay, I'm checking, but it seems that the op-amp doesn't get any power supply. I'm here at ground, just taking some points. I have some 3-leggers here. -11. Good. So I have something, I think it was 1, 2, 3, 4. So I should have here 24 volts compared to ground, and I don't have that. So where is my 24 volts coming from? Okay, so here we have the pin 4, it goes here, 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 here. And we have here a little coil L2 and well, a few caps probably to make the signal clean, and then we have this Q36. Let's have a look here at this coil here, because maybe they replaced this one, there was a short circuit and then this one was blowing. We can at least check here this rail here. I think I found something that is indeed in the 24 part here. Look at this, I think it is C29. It is one of those tantalums. Here it has a completely different color. Also this resistor here seems a little bit darkish brown. So C29, let's go back to the schematic. C29 here, if this one is shorted, then we indeed have no power on the amplifier. And then, yeah, well, this L2 will get very, very hot. So let's just take this out and we can maybe just put a normal one in. Okay, well, the leg broke, but clearly it looks terrible. It looks all burned. I cannot measure it, but when I measured over it, it was like 500 ohms, and now it is a lot higher. So let me see if I now have 24 volts. No, still not there, so I need to go further back on the coil. Right now I have not, so okay, I found it. This, if the channel B is activated, it puts 5 volts here and it should pull this one to ground, and then we have a difference here, and then it opens the 24 volts to the amplifier, to the Philips. But they don't want to have the Philips running apparently if there is no input active. And when I make the channel active, if I measure on this pin, it goes indeed from 24, it pulls it down a little bit like to 21, but that makes sense because here we have a divider like 1/10. So if it goes down around 2.4 volts or 3 volts, then it sort of does what it needs to do. So this one is broken, it just doesn't open. So if I connect this pin to this pin while the channel B is active, I have voltage to the Philips, and then let's see if we have a readout. So okay, we have input, we have the B channel, and now I need to just short circuit the 24 volts. Here, let me check to be sure. So I have 20 volts here, this 24 should be, yeah. This is then the control pin, so if I, where is it, here. So if I switch it over, it is 24 volts, and now it is lower, 21 volts, so it's 3 volts difference, so that means it should open. And now I have 24 here, and I have not 24 here, while it should have been open right now. So if I short circuit these two, we should have readout on the display. So this one and this one, and then we should have a readout. Yeah, and we have, so that's it. Okay, that's it for now. I need to find this ZTX550, and it is a silicon PNP high current transistor Probably need to find a replacement, but it is just an almost an on-off, so it wouldn't be too difficult to do that. But that's it for today. Thank you for watching. Oh yeah, and I'm so glad that the Philips is not broken. Thank you for watching, and I hope to see you next time.